Marginal rays, something is saying marginal, the word marginal. Say ray optics is better, jump into numerical, start practicing it. There's nothing called like a theory. Mirror's formula, you know it, magnification, m equal to minus v by u. Then mirror formula, you know it. And you know some basic idea of reflection. Now, what do you mean by marginal paraxial rays? I think these are the two words which, what all ray optics, what we discuss for what? It is for paraxial rays. Marginal rays means, then sir, what is the meaning of marginal rays here? If marginal rays, if they are incident, then what has to be done? So that you have to apply the laws of reflection, you have to take help of geometry. So I'll let me just revise it. So if the rays are incident, if these are marginal rays, I'll call it, all will not meet at focus. If paraxial rays are there, they'll meet at focus. So this what happens. So that's why the spherical mirror, no, we don't use in any application. We always go for parabolic. So what do you mean by paraxial? So those rays which are incident on the mirror that are lying close to the axis, that one, principal axis called as paraxial. So we take only the small aperture of the mirror for reflection. Only small aperture. I think in so many problems we made condition like this, no? M will be very close to the P. M will be very close to the paraxial. So what about here? M1, you call this as M2 or M1, M2. So marginal rays, what happened? M2 will not be very close to the P. For paraxial rays, M1 will be very close to the P. So therefore, the distance M1, say like a F, should be equal to PF. We do approximation, but not possible. M2P, so that this distance will not be equal to this one. So therefore, what all we study, no, it's a theoretical. Maximum, we always go for the parabolic reflector. But to study this, because parabolic reflector, a lot of maths will be involved. To study ray optics, open the spherical mirrors will help us a lot. That's why we are discussing only the theoretical ideas. We don't have any applications much here. Here and there we use, but maximum will go for parabolic reflector. So this called like a marginal rays. These are marginal rays. For marginal rays, what you should do, you should take help of mathematics, finish or nothing else there. Paraxial ray. For paraxial rays, as we have a formula, mirror formula, magnification formula. With the help of that, we can treat the image. Both the cases, you should apply laws of reflection only. Along with the laws of reflection for marginal rays, the mathematics you have to take help of. I think some 2-3 problems on parabolic reflector are discussed in class. So recollect once and go to the exam. Okay, let's get into the diagram. The aperture diameter of spherical mirror is D. I think I'll show it by sphere. What do you mean aperture? Something is telling aperture diameter. So this diameter, this one, the green color line, it's called, that will be the distance P1, P2, you call it. The P1, P2 is what? The aperture diameter. That is D. What is R? R is the radius. R will be the radius. So how it will be? It will be like a bowl, no? If you practically, if you take it, it'll appear like a bowl. it will be like this. Huh? So you are seeing plane diagram. This will be the 3D diagram. It will be like this. Okay, now let's get into that one. The paraxial ray. It's a marginal ray is incident. Find minimum value of eta for which marginal rays start getting reflected twice. I think there's a one reflection. Afterward, there's another reflection. The rays are incident. After one reflection, then again the second reflection. What can be this angle? This should be 45, 45. Can we calculate the aperture diameter?
Sir.
He is asking that D, no value of D. How much P1 B
Root
will be?
2R.
Root 2R. Huh? Okay, P1, P2, root 2R. Next, find minimum value of it for which marginal rays undergo 3 reflections. Three reflections means there's a ray. One reflection. Two, three, 4. Okay, this is the radius of curvature. This is again P1, P2. Okay, let this be P. Take help of the mathematics now. Again B, this is center of curvature. What about the angles here in this case? How to make out the, definitely this should not be 45 degrees. You can see from here, this angle should not be 45 degrees. So don't write 45 degrees. This will be theta. So this should be theta. If this is theta, this should be theta. And this should be theta. I think we'll trace out the triangles. Theta, theta, theta. This is theta. No. So anybody, can we make
Theta will be 60 degrees.
Yes,
theta
sir.
will
Theta
be,
will be 6.
yeah, theta will be 60 degrees. Okay, theta 60 degrees. Then directly straight away we can calculate the P1, P2
3R.
value root 3.
How did you take they both are equal to theta? Angle at P and angle at
These two angles, huh?
sir, angle at P is equal to theta. P1 PC.
These two angles, huh? I don't know which one you are telling. Okay, I'll put it that one. You mean to say these two angles? Or
No,
these
sir.
two.
He's telling about P1, PC and CP, P2, sir.
Yes, sir.
Once again, repeat.
P1, PC,
P1,
PC,
PC,
and CP, P2.
CP, P2.
Not CPP, CP1. CP.
Okay, I think that these two angles, how they are equal
Sir, how did you?
from geometry.
That only, sir. How?
So you can see from some, you look at this. Are these two not similar triangles?
Sir, we can tell they are equal
Okay.
to some isosceles triangles. C P1 P will also be theta. And
Okay, fine. See
equal to
P1. Okay, this one. Yeah, this will be okay. I'll do one thing. I'll come from geometry. So this will be this. I assume theta. This should be theta. This is 90 minus theta.
Sir, simple logic, sir. Alternate angles, sir. Those both are alternate angles, sir. That's why you took theta.
Sir, CP1P is the reflected angle. That will also be theta. Then we can tell triangle CP1P is isosceles. Like CP is equal to R equal to CP1. From there we can tell that that angle P1 PC is also theta.
Okay, P1C and PC equal to R. This distance is equal to this distance, no? Okay, this angle will be
That angle will be theta, sir. Angle of reflection.
angle of reflection. Okay, this angle will be theta.
Okay, sir. Okay.
Okay,
Understood.
yeah, this angle will be theta. If this angle theta, then what will happen? This distance equal this distance. Okay, fine. Yeah, we'll come like this. Marginal rates. If you see SEORMA, we don't have discussed, but NCERT has discussed even the parabolic mirror. So possibility of asking. Mains or advanced. Be careful. So marginal race comes. So how do we trace out everything? So with the help of geometry. Finish. That's all.